So we're going to square binomials, and the result that we get is going to be something we call a perfect square. So we've seen perfect squares before. If I square one, the result is one. One is a perfect square, right? If you look at a square here, it has a measure of one on each side. One times one gives me an area of one for the square. So that one is a perfect square, or the area of the next square that has two. 2 times 2 gives me an area of 4. The result, or the area of this square, is the perfect square. 3 times 3 gives me 9. The area of this square is the perfect square. The result is the perfect square. So I've listed a number of perfect squares here from squaring 1 all the way through 10. And so we also have perfect squares when we square polynomials. So let's try this one. We have parentheses 3w minus 4 close parentheses squared. Now, I'll tell you what this does not equal. This does not equal 9w squared plus 16. It does not. A lot of times this is the most common wrong answer, and the reason students get this is they try to distribute this exponent over the subtraction. You cannot do that. You can distribute an exponent over multiplication, but if you have addition or subtraction inside of your parentheses, you will have to expand the way you write this. And so we're going to expand this and write parentheses 3w minus 4, close parentheses, times parentheses 3w minus 4. And we know that once we distribute this, we're going to end up with 4 terms simplified down to 3. All right, so let's multiply out the 3w to the 3w and to the minus 4. We get 9w squared minus 12w. Then distribute the minus 4 to the 3w into the minus 4. So we get minus 12w plus 16. Okay, now I tried to be a little clever here the way that I wrote my terms. Notice how I lined these up, my like terms up vertically, and that's very convenient, but we can still see we have 4 terms here, 1, 2, 3, 4. So now let's combine like terms. So we have 9w squared, my like terms of minus 12w and that minus 12w, same sign, add them, keep the sign. So negative 24w, and then bring down the plus 16. So that is my answer. And my answer is what we call a perfect square polynomial. All right, let's try another one. We have parentheses 5c squared minus 6d, close parentheses, squared. So since we have subtraction inside of our parentheses, we do need to expand the way we write this. We cannot distribute that exponent over the subtraction. So we have parentheses 5c squared minus 6d, close parentheses, and again, parentheses 5c squared minus 6d. All right, and I'm going to get my arrows popping. So we have distribute the 5c squared to the 5c squared. Distribute the 5c squared to the minus 6d. That's going to give me 25c to the 4th minus, and then 30c squared d. Okay, let's get my arrows popping again. Minus 6d, I'm distributing to the 5c squared and to the minus 6d. So that's going to give me minus 30c squared d. You notice how we have that term repeated again. And then minus 6d to the minus 6d gives us plus 36d squared. And try to be clever again by lining up my terms vertically for my convenience. Now I'm going to simplify. So we have 25c to the 4th combine your like terms of negative 30 c squared d. We have two of them, so we're going to end up with negative 60 c squared d, and then plus 36d squared. That's my answer. My answer is a perfect square. All right, now your turn. I want you to try these, and then we'll do them together. All right, so this first one here, you have parentheses, 5x plus 2y, close parentheses, squared. So depending on the method that you multiply, you can either FOIL, distribute, or use the box method here. So, but everybody should be expanding this to write 5x plus 2y in parentheses times 5x plus 2y, okay? All right, so with that said, why don't I show the distributive method just so we could see it again. So you're multiplying the 5x to the 5x and 2y in a second set of parentheses. So essentially you're saying this is equal to 5x times the 5x plus 2y. And then the second group, plus 2y distributing to the 5x and the 2y. Okay, so let me just give myself a little bit of space here. Okay, and so we have plus 2y being multiplied to the 5x plus 2y. All right, that's the work we're usually not showing when we're either foiling or just using the arrows for our FOIL. All right, so 5x to the 5x plus 2y gives us 25x squared plus 10xy. Okay, second group, plus 2y to the 5x and to the 2y gives us plus 10xy plus 4y squared. All right, and so we're left with 25x squared plus 20. Notice how this term doubles every time. 20xy plus 4y squared. There's my perfect square answer. All right, let's take a look at this second one here. We have in parentheses negative 2x plus 3 close parentheses squared. So we are going to expand this out. That gives us negative 2x plus 3 times negative 2x plus 3. All right, this time I'm going to use the box method just so we can review seeing that. So I'm going to draw a 2 by 2 box. And then along one side, I'm going to put the negative 2x and then plus 3. Along the other side, I'm going to put the negative 2x and the plus 3. And then show the work inside. So we have negative 2x times negative 2x is 4x squared. Negative 2x times 3 is minus 6x. 3 times negative 2x is minus 6x. There's our repeat term. And then 3 times 3 gives us 9. So we have 4x squared minus the 6x minus the 6x plus the 9. You simplify that, and you're going to get 4x squared. You're doubling your negative 6x minus 12x plus 9. And that is a perfect square as well.